Okay, so question 55 gets a little bit messy, so hang in there with me while we figure it out. Moshi's going to join us. Say hi, Moshi. Good boy. Okay, so 55, what we're looking at here, we have two marbles. One is traveling at a speed of 2 meters per second, while the other marble is stationary at 0 meters per second. Marble 1 is bigger than marble 2, and essentially what it wants to know is the velocity of each of these marbles after they collide. So we're coming down, we're using two different principles here with the principle of kinetic energy and change in momentum. So kinetic energy, since energy is conserved in this problem, we're just doing final minus initial to set that equal to 0. And our formula for kinetic energy is 1/2 mv squared. So I have 1/2 mv squared of the first marble plus the second marble. I have an F written for final, so the final velocity minus the initial velocity, again, of the first and second marble. We set that equal to 0, and then we're going down. You do some plug and chug, because what we're looking for in this problem is our final velocity of v1 squared. So we rewrite that. Final velocity squared is m1v1 squared minus m2v2 squared all over m1. It's kind of the formula that we're getting. But that's not enough, because if you look at it, so we have our final velocity for the initial, but I don't have the final velocity for either the first or last one. I only have my initial velocity. So going down, we're going to throw momentum into the mix. Look, momentum has a very similar formula to kinetic energy, mv, mass times velocity. And we do that exact same setup, exact same thing. We are solving for our initial velocity. Okay? So we take that, we write it out, we plug and chug. We have our velocity final. So we're going to take this formula from our velocity final and plug it into this formula, and then that gives us this. So v final squared equals our initial velocities minus our final velocity all over our initial mass. So there goes some more math. We're plugging and chugging. You're going to get something that looks like that. In this case, what we're trying to now look for is our final velocity of the second marble. So keep plugging, keep chugging. There we go. The final velocity of our second marble breaks down to be 2.8 meters per second. But now we know the final of the second marble, but we still don't know the final velocity of our first marble. So we're coming back over here to the other end of the board. You can plug it into either one of these equations, because they're essentially the same thing, but we're going to stick with momentum because it doesn't have the square root. That makes it easier for us. Plug in the numbers that we've been given, so our initial mass, initial velocity, minus our second mass, and our final velocity, which we calculated to be 2.86, and we divide and get 0.856 meters per second. So that is the final velocity for the first marble, final velocity for the second marble. They're both going in a positive direction towards the right.